Good day to all my dear students. In last video, we have seen square relation, reciprocal relation and quotient relation of different our identities, trigonometrical identities. Now, some questions also we have solved from exercise 16a. Now, to solve from 22 number, we will start in this our video. So before that, students, you must recall all these relations which I told you, that is square relation, reciprocal relation and quotient relation, to understand this question better way. Now let us take question number 22. Now as you know, in this 16a exercise, all the questions are of prove that type. Means we have to start from left side or right side. It is your wish, but mostly it is from left to right. So left side we will start and prove our right hand side. So we will start here our question number 22. On the left hand side here, 1 plus cos theta minus sin square theta upon sin theta 1 plus cos theta. This is given to you. Now first of all you have to think that all sin and cos given, so you must find some relation in between the terms, that from that you can get something. Like in the numerator, if I rearrange the terms, like there is 1 plus cos theta minus sin square theta, I will take 1 then minus sin square theta and then plus cos theta, students. Why I am doing so? Because I want some relation of 1 minus sin square theta. So now after rearranging the terms as 1 minus sin square theta plus cos theta, denominator as it is sin theta 1 plus cos theta. Now you have learned already one square relation, sin square theta plus cos square theta is equal to 1. So if I take sin square theta on right hand side of this equation, that will be 1 minus sin square theta and the value will be cos square theta. So I place 1 minus sin square theta value as cos square theta in the next step plus cos theta and the denominator as it is. By doing so, you have to think that in the numerator we have only cos, means first term is cos square and the other term is cos. So we can now take 1 cos theta as common and write the remaining in the bracket. So likewise you get the next step as taking cos theta common and then cos theta plus 1 in the bracket. Denominator sin theta 1 plus cos theta. So you can check 1 plus cos theta or cos theta plus 1 same, that I have cancelled, and then I have only remaining cos theta upon sin theta. But according to our quotient relation, cos by sin is equal to cot. So that we get cos theta upon sin theta is equal to cot theta. That is our right hand side. So students, in every question there will be different relations. You have to think here and you have to start your proof, that how you will complete the proof using which relation. Now moving to next question. So next question, I am taking question number 23, in which left hand side is equal to 1 upon 1 minus cos theta plus 1 upon 1 plus cos theta. So here also you observe the question, you have 1 in the numerator and denominator 1 minus cos and 1 plus cos. Okay, so here how can we solve? So first of all we take LCM. So for LCM, 1 plus cos theta we will multiply upside with 1, that is 1 plus cos theta only, and 1 minus cos theta will multiply with that 1, it will be 1 minus cos theta. Denominator 1 plus cos theta 1 minus cos theta, means both the brackets in multiplication. So now the numerator you see 1 cos with plus sign and 1 cos with minus sign, that get cut, and 1 plus 1 become 2. In the next step you can check 1 plus 1 is 2, and denominator you can check that a minus b, a plus b type of expansion or factorization. So you remember our 9th standard factorization chapter, in which a plus b, a minus b means we write as a square minus b square type. But here a means 1, So 1 square is 1 and cos theta square, that is cos square theta. So we get 2 upon 1 minus cos square theta. We have to remember our 9th standard content also here to solve these questions. Here sometimes we are using our different identities of 9th standard which we have already learned. Now next step, 1 minus cos square in the denominator, that relation is square relation, sin square plus cos square is equal to 1. From that 1 minus cos square I have written sin square theta. So 2 upon sin square theta. Now 2 I have taken separated into 1 upon sin square theta. So 1 upon sin square theta is nothing but cos x square theta, that we all know as our reciprocal relation 1 by sine is cosec. So 2 cosec square theta is equal to right hand side, which we have completed here our question number 23. Now taking the next question, question number 25. In that left hand side is equal to 1 upon sec theta plus tan theta is given, and you have to get your RHS in form of sine and cos. So student, sec theta and tan theta, you see, if you convert it in a sine cos manner, it will not give you this relation what you want on the RHS. So what we have to do is, sometimes we multiply something and divide it so that it will work. Here you see what I have taken, multiplication sec theta minus tan theta, and denominator also sec theta minus tan theta, means multiplying same and dividing same. It means nothing done but something we need from it, like that. So here by multiplying the same and dividing the same, sec theta minus tan theta in the numerator, and denominator it is a plus b, a minus b type of expansion. So again I rewrite it as a square minus b square, like sec square theta minus tan square theta. Now sec theta minus tan theta in the numerator, but the denominator is sec square theta minus tan square theta. That is our square relation, and the value of is 1. So you put the value 1, where is sec square minus tan square. Okay, now that is sec theta minus tan theta we get. So sec theta is 1 by cos theta minus tan theta is sin theta upon cos theta. So here we converted afterwards in sine and cos, and then you check in the numerator, in the denominator cos cos. So the numerator you can take as 1 minus sine theta upon cos theta, which is your RHS, right hand side. So students, sometime you have to check the right hand side what you want. According to that you have to take your left hand side, and what you have to multiply sometimes, and sometimes what the adjustment you have to make, that you have to understand and observe the question. Likewise by practicing you will understand how to solve. Now 26 number question, left hand side is equal to 3 brackets are given, cosec a minus sin a, sec a minus cos a, tan a plus cot a. So here first of all we convert all the reciprocal relations as sine, cos and sine cos. So here cosec is 1 by sin a in the first bracket minus sin a. In the second bracket sec a means 1 by cos a minus cos a. Third bracket tan a means sin a plus upon cos a, and cot means cos a upon sin a. So we have converted all of them in sine and cos. Now in the different brackets we have to take LCM to solve them. So in the first bracket 1, then sine in the denominator. So the next minus sin a also we multiply by sine. So 1 minus sin square a upon sin a. Second bracket denominator is cos. So by multiplying cos a I get 1 minus cos square a upon cos a. And then third bracket 1 sin and 1 cos. So with cos multiplying sin and with sin multiplying cos. So we get sin square A plus cos square A. Denominator is sin A into cos A. Okay, so all of them, no sign in the middle of the brackets means it is multiply sign, which I have kept in the next step. Now 1 minus sin square is cos square A. So in the next step, it is written cos square A upon sin A into 1 minus cos square A is sin square A upon cos A into sin square A plus cos square A is 1 upon sin A cos A. Now in the denominator, see, sin into sin means sin square A. In the denominator, cos A into cos A, cos square A, and numerator already sin square A and cos square A given. So we cut all of them and we left only 1 there as our right hand side. So we have started from our left hand side, converted all of them in sin cos, and then using our square relation we get our right hand side as our final answer. Now taking next question 27. Left hand side is equal to 1 plus sin theta upon 1 minus sin theta, and we need our answer in the form of sec and tan. You check your right hand side, you will come to know. So here also only with sine we cannot do anything, so we multiply upside down the same thing, that is 1 plus sin theta upon 1 plus sin theta. But some of the student must have that question that how we decide that we have to multiply this thing and divide this thing. For that, you see in the denominator it is 1 minus sin theta. So if you multiply same 1 minus sin theta, it will become square of it. That we don't want. We want 1 plus sin theta, that is the sign different of it, so that we can use our a minus b, a plus b type of expansion identity, that is a square minus b square, that will work. Okay, so now understood how we are deciding the what to multiply and divide. So now after taking multiplying 1 plus sin theta, 1 plus sin theta, both the way in the numerator we become we have square of 1 plus sin theta whole square, and denominator as I told you that it become a square minus b square type. So 1 square 1 minus sin square theta. Now numerator same 1 plus sin theta whole square, but the denominator is 1 minus sin square theta, and the relation sin square plus cos square is 1. From that 1 minus sin square theta is cos square theta, as we all know. Now you see numerator also having square and denominator also having square, so we can separately written instead of writing separately, we write whole square as one bracket. You check 1 plus sin theta upon cos theta whole square. Okay, then what we have done, that I have taken separate ratios, that is 1 upon cos theta plus sin theta upon cos theta whole square. But 1 upon cos theta is sec theta plus sin upon cos theta is tan theta whole square. That square remains everywhere, but the after taking the separate ratios we get them as sec theta plus tan theta whole square. So here we get our RHS in this way. So you can check in the next step that sec theta plus tan theta whole square, we get our right hand side in this way. Okay students, let us move on to next question. Next question is question number 29. Question number 29 is, left hand side you check cot theta plus cosec theta minus 1 upon cot theta minus cosec theta plus 1. So here student, if you convert this cot theta and cosec theta in cos and sine, that will not work to means that will not give our answer. Okay, so what we are doing in this type of question, 1 is there at the last in the numerator also and denominator also. So I will place the value of 1, that is we have 3 square relations, one with sin cos, one with sec tan, and the third with cosec and cot. So I am using the third one, that with cosec and cot. What is our square relation with the third? That one value will be from cosec square minus cot square. So I am placing instead of 1 in the numerator cosec square theta minus cot square theta. So see the next step, cot theta plus cosec theta minus in the bracket value of 1, that is cosec square theta minus cot square theta. Denominator we keep the same. Now by doing so, cot theta plus cosec theta as it is, but now this is a square minus b square type of bracket. So we factorize it as cosec theta minus cot theta, cosec theta plus cot theta, and the denominator as it is again. Now cot theta plus cosec theta in the bracket that we have taken common. Students, there are two terms. One is cot theta plus cosec theta, then minus sign, then two brackets. So you check before minus sign first term and after minus sign second term. So out of them cot theta plus cosec theta is common. So in the big bracket I have written 1 already, which is taken common. For that 1 minus cosec theta minus cot theta in the other bracket upon cot theta minus cosec theta plus 1. Now cot theta plus cosec theta first bracket as it is, then outside the smaller bracket minus sign. So when we open the bracket, sign changes. So 1 minus cosec theta minus minus plus cot theta upon cot theta minus cosec theta plus 1 as it is. Now the whole second bracket is same as the denominator. You check 1 is there, then minus cosec theta minus cosec theta, and plus cot upside down, and there is multiply sign upside also. So we can cancel that whole bracket upside down. So we get only cot theta plus cosec theta as our remainder. Now here we get answer in sine and cos form. So what we will do here, we change our cot as cos and sine, and cosec also. So see, I have written in the next step, cosec means 1 by sine theta plus cot means cos theta upon sine theta. Now the denominator same. So in the numerator 1 plus cos theta upon sine theta. Okay. Now here we have to prove two things. You can check the question. Is equal to this, then is equal to another thing. So first I have written number 1, that is our first part, cosec theta plus cot theta, and the second I have written, that is our second part, 1 plus cos theta upon sin theta, which we want to prove. So that is completed. I have written that RHS, right hand side, done. Now some of the student must have this type of question, that why not we have kept the value of 1 in the denominator. Yes, so it is not compulsory that you have to put the value in the numerator only, but either of the one place you can place the value, either in the numerator or in the denominator, but not at the both place. Then only you get the right answer. Okay, so now moving to next question, 30. Question number 30, you are given, means in the question you read, if tan theta plus cot theta is equal to 2, then prove that, right? So whenever if part you are given, you can use to solve your question. Okay, so here I am taking tan theta plus cot theta is equal to 2. Now squaring both the sides, I have taken tan theta plus cot theta whole square is equal to right side 2 square 4. Now this is left side a plus b whole square type of expansion identity. So I will take the square of first term, that is tan square theta plus 2ab means 2 tan theta cot theta plus cot square theta is equal to 4. But students, we know that tan theta and cot theta are reciprocal of each other. So tan square theta plus 2 into 1. Why? Because tan and cot reciprocal of each other become 1, plus cot square theta is equal to 4. So now tan square theta plus cot square theta on the left side is equal to 4, and the 2 from the left side go on right side become minus 2. So tan square theta plus cot square theta is equal to 4 minus 2, 2. So we have proved here what we want to prove. Tan square theta plus cot square theta is equal to 2. Likewise, we can solve any question. If part is given, you can use that if part to solve your prove that type of questions. So now let us move on to question number 31. Here also you are given if sin theta plus cot theta is equal to A and sin theta minus cot theta is equal to B, then we have to prove that A square plus B square is equal to 2. So here values are given of A and B. So we will start with left hand side is equal to A square plus B square. Now placing the value of A here, instead of A I write sin theta plus cos theta whole square, and instead of B, sin theta minus cos theta whole square. Now whenever whole square means A plus B whole square type of expansion we have to do here, sin square theta plus 2 sin theta cos theta plus cos square theta, and the second bracket is A minus B whole square type of expansion. So sin square theta minus 2 sin theta cos theta plus cos square theta. Now you check that in the whole expansion plus 2 sin theta cos theta and minus 2 sin theta cos theta get cancelled. So we have 2 sin square theta and 2 cos square theta. So I write here 2 sin square theta plus 2 cos square theta. Now in the next step, taking 2 common. So I get in the bracket sin square theta plus cos square theta. Now this is our square relation 1. Sin square theta plus cos square theta is 1. So I place the value 2 into 1 is equal to 2. That is our right hand side. So here we can solve any questions like this. If part we have to use and get our right hand side. Thank you.